Okay, so this is Chapter 15, number 5. So the Hudson Corporation is considering three options for managing its data warehouse: continuing with its own staff, hiring an outside vendor to do the managing, or using a combination of its own staff and an outside vendor. The cost of operation depends on future demand. The annual cost of each option in thousands of dollars depends on demand as follows. And they give us this table. The demand is high, medium, low, and then the staffing options are own staff, outside vendor, and combination. And then these are the values of the cost of each option. Okay. Now, if the demand probabilities are 0.2, 0.5, and 0.3, which decision alternative will minimize the expected cost of the data warehouse? What is the expected annual cost associated with that recommendation? So what we need to do is calculate the expected values. And so we're given the high, medium, and low, and we just put those probabilities and multiply them times the demand costs. And what we see is for the expected value, we're going to take the 0.2 times 650 plus the 0.5 times 650 or plus the 0.3 times the 600, and we get 635. That's for the own staff. Then outside vendor, we do the same thing: 0.2 times this, 0.5 times this, and then 0.3 times that, and we get 570. And then we do the combination: 0.2 times this, 0.5 times this, and 0.3 times that, and our expected value is 635. So the optimal decision is to hire the outside vendor because it's the minimum expected value, okay? And that's at $570,000. So that's the expected annual cost associated with choosing that outside vendor. Now it says construct a risk profile for the optimal decision in part A, and what is the probability of the cost exceeding $700,000. All right, so we chose this outside vendor, and so what we need to do now is need to construct a risk profile. So basically, we're just going to go from low to high, so 300 to 600 to 900, and then put our probabilities here. And so this is going to be our risk profile. The cost 369, and then a probability is 0.3, 0.5, 0.2. Okay, so that's what it is. Now, the probability that it exceeds $700, well, up through 600, it's 0.8. So then exceeding that would be 0.2. So anything over that would be 0.2. And so that's what the probability that we exceed $700 is. And then we can do the graphical representation. Basically, we just put a bar graph here. And if we want to see how that looks, hopefully it'll come up. And I just, put the table here, told it to do the bar graph, and that's what I did there. And so I just inserted, and then just the bar graph I chose. I guess I have to tell it which one. And then I said, okay, well, go to all charts, and then I did a bar graph, and then I just had to make it work to get the right labels here. And that's how we solve this problem. And so we've done part A, part B. So hopefully that helps you with something like number 5.